Hello and welcome back to Baldy Cats. Let's get started.
Just taking a quick run to the store. Figured I'd go over a quick little experiment that I learned about the other day that absolutely destroys gravity.
In my near 12 months on YouTube, I've seen a lot of flat earth arguments, and to me they all tend to fall into one of three categories. Type 1 is an argument that is so stupid you have to believe the person making it is literally just having a laugh. Type 2 is a type of argument that you can address with just a little bit of a refresher on high school physics. And Type 3 is an argument that makes you stop and think, and sometimes you can really understand why the person making it has drawn the conclusion that they've come to. And today I'm going to show you one of each argument, and I'm going to explain some of the stuff I had to learn in order to deal with type number 3. But let's get back to type number 1 and internet's favourite flat earther, that guy.
So here's the experiment. Go to Walmart, get you one of those tanks of helium that fills up birthday balloons.
Okay.
Weigh it when you get home. Shake it, you'll feel there's a liquid inside. Weigh it, see what it weighs. Now take that same exact helium that's in the tank and put it in a gigantic balloon, or many small balloons.
Are we having a party?
You empty the tank into a balloon, that exact same 10 pounds of helium will now float away from you when you let go of the balloon.
Right, so let's just clarify your argument. When I have helium in a heavy metal tank, it won't float. And when I've got it in lots of little balloons, or one big balloon, it will float. Okay.
Gravity cannot explain this in the least bit.
Ladies and gentlemen, that is a type 1 flat earth argument, and I will not insult your intelligence by explaining the answer to you. However, let's look forward to that guy's next video, because as he tells us in the description, his next video is going to be on the physics of orbital mechanics. And I'm sure if those videos are anywhere near as detailed as the helium in a tank video, they are an absolute must-watch. So flat earth argument type 2 comes from a guy called Gleam. Now Gleam is a regular contributor in my comment section, and I'll be honest, the guy's growing on me a little bit, but this is what he's got to say. Gleam is a little upset with me because I keep saying that the observations of Polaris could not work on a flat earth, but he's done the calculations and he says they can, and he's annoyed at me because I never actually in detail explain why the observations of Polaris cannot work on a flat earth. So here we go. So on this diagram, X marks the axis of rotation, and if we were to stand on the axis of rotation in the northern hemisphere and we were to look right above us at 90 degrees, then as near as damn it, Polaris will be right overhead. Now, what we know to be true through observation is if we move 111.3 kilometers south from the axis of rotation, then the angle of Polaris will drop by 1 degree in the sky. So now we're viewing it at 89 degrees. This gives us a right angled triangle, and simple trigonometry tells us that if we want to calculate the distance to Polaris, which is represented by what we call the opposite of the triangle, the blue line, then I take the tan of the angle and I times it by the adjacent, which is the 111.3 kilometers. And that gives us on a flat earth a distance to Polaris of 6,376 kilometers. Now, the problem for flat earth begins when I start to move. So here, I have moved 45 lots of that 111.3 kilometers, and now the viewing angle to Polaris is 45 degrees from the horizon. But if I redo the maths, then now Polaris must only be 5,008.5 kilometers away. So Polaris must be in a different position for me than it was for the observer at 89 degrees. And if I was to move 70 lots of that 111.3 kilometers until the viewing angle to Polaris was 20 degrees above the horizon, then tan of 20 degrees times the 7,791 kilometers I've moved puts Polaris at 2,835 kilometers away. So in other words, wherever I am on the Earth, Polaris must be in a different position for me than from an observer at a different latitude. So Gleam, if you are watching, that is why observations of Polaris will not work on a flat earth. But to be fair to you, I will put your argument into the video just to show everybody what you did. Although having said that, I'm not too sure exactly what it was you did, so I'd love your feedback in the comment section. But credit where credit's due, at least Gleam did have a good go at trying to work it out and show why I was wrong. Unlike Nathan Thompson when I debated him on Simon Dan's channel, and Nathan Thompson refused to engage on this point because I was using the metric system.
How would you calculate that distance? Using trigonometry, how would you do it, Nathan? So your argument is that the north, I personally can't calculate that. I don't work in kilometers. I normally work in miles.
So that's an example of flat earth argument type 2. Not overly technical, but we do need a little bit of a refresher of what we did at high school in order to understand it. But here comes a big one, type 3. Now, this is one of the better flat earth videos that I've seen, and it's still wrong, but I can understand why he comes to the conclusion he does, which is that rockets can't work in the vacuum of space and they need air to push off. Before we see the rest of his video, let's just refresh ourselves with Action Lab's video where he proves beyond doubt that rockets do work in a vacuum.
Whoa!
Now that's just a kind of pop exploding in a vacuum chamber, but if we slow that right down, this is what we see. So what we see here is within a single frame of video filmed with a high-speed camera, as soon as that pop leaves the can recoils off in the opposite direction. There is no air in that vacuum chamber, and the pop isn't anywhere near the walls of the container. The pop is literally pushing off nothing, but yet the rocket, in this case the can of pop, is still moving and recoiling. And that is caused by the law of conservation of momentum. The pop or soda leaving the can in one direction will have a momentum which is matched by the can travelling in the other direction. So the mass times the velocity of the soda moving to the left will equal the mass times velocity of the soda moving to the right, or vice versa. Now, the faster the soda leaves the can, the bigger the momentum it's going to have, or the more soda that leaves the can within a single second, the more momentum it will have, which means the can will have more momentum and it will move faster in the opposite direction. So let's have a look at how our flat earther tries to tell us otherwise.
So what we can do is put a little shield in here, a little column, and this will interrupt the surrounding air pressure, which is all angles. It's not there now. So when the air rushes out, let's see what happens when there isn't this air pressure pushing in from all directions simultaneously everywhere. When that doesn't happen, what happens to the thrust? Again, put a lot more in.
Okay, so without the tube, we got this. So here, the momentum of the air leaving the bottle is the same as the momentum of the bottle going forwards. So why does putting a tube on cause it to do this? So when I saw this, my gut feeling was, well, maybe adding the tube increased the mass of the rocket so much that the force produced by the rate of change of momentum of the air coming out of the rocket wasn't enough to overcome the frictional forces of the extra mass of the tube on the rocket. But he debunked that pretty quickly with this.
Now we can test this. Same column in with holes. Great suggestion from Pete and Pete.
Did he just say Peter and Pete made a great suggestion?
Absolutely.
Recommend checking their channel out. Take the nonsense apart one episode at a time. Excellent. Here we go. This one is for use.
So now the bottle rocket works again, and he's come to the conclusion that by putting holes in the tube, air can get inside the tube, so the air coming out of the bottle can push off that air, making it move forward, which obviously is wrong, but I couldn't quite figure out what was going on. Another thought that passed my mind is it may be working slightly like a suppressor on a pistol, because that reduces recoil like this. Now, a suppressor works because the diameter of the suppressor is much larger than the diameter of the barrel of the gun. And when the hot gases leave the barrel of the gun, they expand and immediately drop in pressure. This lower pressure means they leave the suppressor at much lower velocity, and therefore the change of momentum of the gases leaving the gun is much smaller, which means the change of momentum of the gun in the opposite direction, or the recoil of the gun, is much smaller. Now, this sounded like I was getting close to the answer to me, but not quite 100%. So I looked up something called Reynolds number.
Reynolds number.
And quickly realised that it was pronounced Reynolds number.
is equal to the density times the velocity times the characteristic length over the viscosity of the fluid. Its significance is the ratio of inertial forces to viscous forces on a fluid element.
So how might this be relevant? Well, if the ratio of these inertial forces over the viscous forces is less than the order of 10 to the 3, then we get something called laminar flow in our gas. Now, laminar flow gives us a very ordered and predictable flow, like this. But if the ratio of those inertial to viscous forces is greater than 10 to the power 4, we get something different called turbulent flow. And this is what I thought could be the answer. So we can see with turbulent flow, as the gas leaves the bottle into the tube, it very quickly expands in different directions and loses velocity along that horizontal component, which means when it leaves the tube, it's traveling slower, giving us a lower change of momentum, giving us a lower recoil on the bottle. But to me, that didn't really feel like the right answer. Although it explains why the air would leave the tube at a lower velocity, it doesn't really explain why there should be less recoil as the air leaves the bottle into the tube. Something has to be slowing the air going from the bottle into the tube in order to reduce that force. So I reached out to a couple of people. Godless Engineer agreed with my final thought that as the air leaves the nozzle into the tube, it has to expand very, very quickly, therefore increasing the pressure where the tube meets the nozzle. This means that the air coming out of the bottle into the tube has to travel more slowly with a lower change of momentum, therefore producing a lower recoil. Now, I was really happy with that explanation and I was good to go on this video until I heard back from this man.
Hello people, here I am.
So this guy's called the Rumpus and he's a really clever guy. And although he didn't disagree with my take on what's going on in the bottle and the tube, he knows that there's a lot more that can be added. So rather than take his explanation and make it my own, I've invited him onto my channel to do a 2 to 3 minute presentation of exactly what's going on inside that tube and why when the tube is there, the bottle rocket won't work. I'll hold my hand up. I couldn't fully debunk this one myself, but I've really, really enjoyed learning all these different things as I go along. And I look forward to showing the Rumpus's final explanation, hopefully in a week or so. Important channel update. So most of you know that I've already got 2 channels, and my main channel, the bigger channel called Conspiracy Catz, I've linked in the description if you're not aware it exists. Now, Conspiracy Catz is a little bit silly and a little bit less scientific, and it has lots of silly bits in it. Well, I'm opening up a 3rd channel called The Conspiracy Cat, where I'm just going to put the best snippets of silly bits from Conspiracy Cat. So anybody who wants to chuckle, anybody who wants to watch, for example, the A-Team clip from the last video, or listen to the P1000 song, they're all just going to be placed on the Conspiracy Cat channel for people to watch in different playlists and just have a laugh to. So nothing serious, just the silly stuff, and perhaps some covers of my songs. I've linked that in the description. Check it out if you want to, and I'll start uploading videos on it very, very soon. Up until then, I'll see you later.